Hello and welcome to Simplified AI. Today I'll be breaking down the Bellman equation. Let's start off at the VS. Okay, so what is VS, right? VS is like your current state. Now, to give a good analogy, you have a goal, and this goal is to become a very successful entrepreneur or to become rich, right? So how would you measure that success? Where are you in your current state relative to your goal? Now, your current state kind of be like your current balance, your current progress measurement. Where are you? You've got a lower state, and then you sort of want to work towards a higher state. You're in a map. Here's Doggo. Doggo is our agent. Doggo doesn't like vacuums. He gets a -1 reward. Doggo likes trees. These arrows are the actions that are available for Doggo. So you've got this action, this action, and this action. Now these squares are the current states. So he's in this current state right now. It hasn't taken an action. It could be an action of 0 or whatever. He's in this current state. What is the maximum action to give him the biggest reward for the action taken in this current state, which is here, which is there, plus that by y, which is gamma. Now, you imagine if I place Doggo anywhere around here, say here, how is he going to know whether or not to go left or right to reach the goal? Now, he may experiment and take out all these, but he's got a 50% chance of making the right decision, which in this case could compile and just make a poor model. What you want to do is basically have a way of wherever you place him on the map, he will know to go this way over going this way. You place him here, he'll go this way. You place him here, he'll go this way. He's not going to go this way. The way you do that using y, you might wonder why. Imagine if you take a step, and each time you take a step, you get minus. You get like a discount. It's kind of like a health bar. Every time you take a step, your health bar goes down a little bit. Let's take a step, it goes down a little bit. Step takes it goes down a little bit, but it's a measurable change. The reason why we do this is because if Doggo is here and he decides to go here and experiment and whatever, decides to come back and reach his treats, then he realizes instead of going here and wasting time with all this, he can chuck all that information away and go this way instead. This will be a more favorable option over wandering through the abyss. This is the goal. He'll figure out that's the most optimal policy and for him to execute. If you think about the last area, this P, it stands for probability, right? So you've got R, which is a reward. You've got S, which is a state. You've got A, action. Y, gamma. S prime, it's the next state. This next state will end up this state. P, probability, like a good way to explain it. So if I go through and do it all mathematically, it's just going to sound like a whole lot of jargon. So the best way I found to explain this is to imagine Doggo wants to go down, but something in his head just makes him go left, makes him go right. 20% of the time he goes left or right. The 80% of the time he goes the direction he should be going, which gives him the maximum thing, instead of just giving one way, because there could be other options for it to explore and become more efficient. Think about how our world works. Imperfection is what makes it perfection, because he has a little bit more freedom to explore and not go the definitive direction, opens himself up to more opportunities to be more efficient and grow as a doggo. Doggo will be trying to get there as quickly and as safely as possible, avoiding any minus rewards, any vacuums. I want to arrive at treat. That's the definitive decisions. Like, that's the best decision that it makes, that it could make, is to go this direction to reach its goal. And I mean the values, right? So you've got 10, 9, 8, 7, 6, 5, 4, 3, 1. Okay, Doggo wants to climb the ladder and go this way. But in that process, he could be going this way, that way, any other direction. And in the direction towards treats, there's some probability. So he might find a ball and get distracted and just completely forget about the treat. And just adds in some probability. It's fun to learn things. Nice.